And I think we're going to be joined on the stage by two of our colleagues from the first half of this session. I would say that I've taken away from this discussion a very profound sense that we cannot focus on just one solution. We have to drive all solutions forward very vigorously to have a hope of making the transitions that we need, and that there's many different ways to approach that. Rather than dominating the discussion myself, I would like to open this up for questions from the audience. And I believe you should step to the microphone and ask your question.
I've got a naive question. I'm puzzled with respect to the coal and the effects of transporting it and so forth, how those industries were able to avoid legal liability for all the harm they cause. I can see maybe the state level, but eventually wouldn't the Supreme Court catch up with them and say you actually have to pay for the harm you do?
So again, can you hear me?
Yes.
Bruce Nellis. So on the coal dust coming off coal trains, we actually did bring at the Sierra Club, bring the first case in the nation raising concerns about all this coal dust blowing off into lakes, rivers, and streams, because if you and I took dirt from our yard and dumped it into a river, that's illegal under federal law. So we actually brought the first case in the nation 2 years ago and have BNSF, the big railroad provider, actually on track to identify how it is going to eliminate coal dust coming off its coal trains, A, and B, it has to go back and clean up a bunch of sites where we demonstrated to the judge there were a bunch of places where this dust has come off by the ton, and it's just sitting there on the bottom of the lake, river, and stream. So there's a cleanup process beginning. They do, as Clip noted, there's this problem with certain kinds of coal that will combust if they're in an enclosed area with moisture. So they got to work out how they're going to manage that. But I agree, it's the only, as noted in the clip, it's the only industry that ships and loses a significant amount of its product from where it starts to where it finishes.
Right. I see another question.
We only heard very briefly about batteries. Could someone comment on the status and the rate of progress on batteries and how far we are from a point where they are a reasonable alternative for load leveling? Thank
Sure.
you.
In the last 8 or so years, let's say round up to a decade, the cost of batteries has come down by roughly a factor of 10 from 2008 to 2018. It's going to continue to come down another 2 or 3 written into the cards based on technology. The first factors were just economy of scale. In terms of low-level things like this is utility-scale batteries, very different from closed lithium-ion batteries. The feeling is that the allowing flow batteries, other types of batteries, new technologies that don't have, where weight is not a premium, volume is a premium, because the battery costs actually have a lot to do with the footprint of the tens of megawatts to gigawatts. California will need several gigawatts and gigawatt hours of battery storage by 2025 because of the solar and this duckback problem. So I'm very hopeful that the cost of batteries at utility scale will go well below $100 kilowatt hour. Pump storage is $10 a kilowatt hour. And so one of the things we have not done is to utilize as much pump storage with existing hydro plants as possible. And it's not only, we're not talking about building new dams, we're talking about building 2% storage ponds below for what exists above. And so if you recognize that chemical batteries will not get to pump storage for a half century more, we might as well use the old technology that we know about. But the batteries are going to be crucial in going to get above, let's say, 50% renewables. Yeah. I just want to add one more thing, and that is, California is turning its back on nuclear. I'm appalled. I'm trying my best to slow that up, but this is happening. And I keep on telling people, we don't need nuclear for California will be 50% renewables by 2030. We're already 30%. We need nuclear for the last 30% of electricity. And that's the thing that people have to focus on. The first 50%, actually, is pretty easy.
If I may add, I did not have time to go into that, but when it comes to storage, there are different types of storage. So definitely battery is something that we look into. But what we are doing as an agency, we're investing in different types of storage. But what I was trying to show today with the notes program, we are actually exploring how much of physical storage, either electrochemical or thermal, we really need, and how much of flexibility we can extract from consumption. And what's the ratio, and that would also help with the price of the electricity and deployment as well.
Okay.
Let me just say a couple of things. One is that storage isn't pie in the sky. We have 2% of all of our electrons in the U.S. are stored right now in pumped hydro storage, and the efficiencies of those have been improved. That's under the radar. All of the battery articles don't talk about that. The other is the largest scale storage in the world for electricity is in hot water heaters in France, where there are 30 million electric hot water heaters under direct load control of Électricité de France. That's where they dump the nuclear power at night. Works very well. But on the bad side, it's going to be really tough to come up with mechanisms that pay for the storage. At gigawatt scale, at, say, 20 gigawatts in PJM's 120 gigawatts, the opportunity to buy low and sell high disappears because they cut their own throat. And so we've got to come up with interesting market mechanisms to pay for storage if they're going to play a larger role.
Okay, great. I see another question.
Yes. Before I ask the question, I just want to call attention to a National Academy of Sciences Sackler colloquium that will be on the scientific status and challenges in decarbonizing our energy landscape this fall in Irvine, California. And I hope a number of younger scientists will be able to attend that. My question relates to the notion of centralized versus distributed energy, and particularly in the developing world, where you don't have large installations of grids or smart grids, and the notion of how one is going to have energy distributed to people in that kind of environment, and what your thoughts are with regard to that.
Because I had dinner last night with our former student, Dan Schnitzer, who has a company called Spark Meter that's selling to 150 microgrids around the world, I can say that the policy mechanisms are getting more robust for local generation in developing countries. Now, this could be coal, it could be small-scale hydro. Often these days, it is photovoltaic, and that makes a fair amount of sense. But again, even though the costs are dropping, you can buy a smart meter now for $20. There are policy mechanisms that are required to introduce them at large scale that we're not seeing in many parts of the world where it matters. I think there's a big opportunity for doing that, but it requires some real policy intervention.
So just to add to Jay's point, so I think it's, appreciate the fact that particularly for greenfield situations where you do not have an existing grid and so on, there is a different opportunity now available with maybe not quite yet in terms of the cost, but as Secretary Chu mentioned, we are going to see the costs of distributed solutions fall, and therefore they're certainly going to play a much greater role. We see that with our work through our Tata Center at MIT in the electrification of India. But I think rural India and the role of microgrids and so on. But I think you're going to see, a balanced situation emerge, because those smaller scale systems, renewable centric and so on, are often not going to be able to drive the economic growth that many of these countries require. So it'll be a balanced system, but I think these new technologies will at least allow an acceleration which wasn't previously possible.
And if I may add a little bit more, because we actually looked into what would happen in the United States when it comes to decentralization, or keeping the central solution to grid management, you have to take into account fact where actually sources of renewables are. So you probably will in US end up with the architecture of a grid where you will have a mix of distributed and centralized, because we will have to basically bring power to the consumers. And we did look into some projections of loads of generation. It looks like it's not going to be that hard to provide distributed power to residential customers where you are having difficulties when we are talking about big industrial consumers or a large urban environment.
One final comment. If you, anywhere where you have to truck in bunker fuel oil or diesel fuel, renewables, including storage, is a no-brainer. There is a little bit of resistance because there are a number of people selling diesel generators and diesel fuels saying, no, what you want is reliability. And what you need to do is to teach people, use that as a backup, because that electricity is all OPEX costs. And amazing things can be done once you're off-grid to bring electricity. So there's a real opportunity for leapfrogging. That's mostly in developing countries, but in even Western Alaska will never be connected to the U.S. grid, or never is a long time. So let's say this century. But remarkably, when I was Secretary of Energy, they've just put up a turbine. They were very proud of it. A lot of the time they were warming up the ground with it. And I said, why don't you have, it's Alaska, there's a big apartment-like complex with a central water heater. Why don't you warm up your water heater? They're blinking at me. So there's a bit of education as well. But anyway, so.
Well, additionally in U.S. you have lots of rural portions of U.S. that are interested in decentralized and distributed solutions. So we as agency are working closely with the National Rural Electric Cooperative Association that actually controls about 70% of the land in U.S. And they have somewhat different priorities than when we are talking about, as I said before, cities and large consumers. And that's probably where we will see some of the first serious deployment of distributed energy.
We're going to do 3 quick points. Okay, let me go to our. We have two more,
go to your last question.
We have 2 more questions. He was waiting first.
Okay, so I think this. I'm Kerry Emanuel. I'm a climate scientist at MIT, and I have a particular interest in seeing rapid decarbonization and quite agnostic about how we do it. But I'm impressed by the fact that both Sweden and France managed to largely decarbonize their power sectors in about 15 years and wonder why we can't do that. My real question is, this panel, with the exception of the last speaker, was largely US-centric. But most of the growth in carbon emissions is expected to be outside the developed world. So whatever we do is going to have to be marketable there. And I'm impressed by the fact that both Russia and China are building nuclear power plants for export. So is it not just a matter of decarbonization, but also a matter of our national security and our economy to beat them at that process?
Okay, and why don't we get the last question and then we'll do them all together, please.
This is a question for the future, not the present. Thermonuclear has not been mentioned. I think there are reasons. However, as we saw, there are times when new ideas change things dramatically. And in fact, in thermonuclear, the development of high magnetic field fusion reactors seems a possible game changer. Can anybody comment on that?
Okay, so let's, we'll start with Ashley and we'll come around to all of these points. Let me grab your.
I'll say a little bit about both questions. I think that to the last question, there is dramatic investment in fusion technology now in the private sector as well, and there have been advances in superconducting materials and things that have really made a big difference. There's a project at MIT called SPARC that is looking to really focus on commercialization of fusion. And for a long time, fusion has been more focused on science and less on electricity. But I'm seeing a real change in that, and I think it's very exciting. And they are really looking to be commercialized in the next couple decades. To the national security question, I agree wholeheartedly. It's very important for our national security that we continue to be a player in the global nuclear markets. Russia and China, particularly Russia now, but China in the future, use energy relationships for geopolitical purposes, and those have major impacts around the globe. We need to be part of that game as well. We also need to have a seat at the table when there are standards being set around nonproliferation, safety, and security for nuclear around the globe. And we will not have a seat at that table if we do not continue to be a major player in nuclear, commercial nuclear technology. We used to be a player in light water reactors. Now I think we're really being overtaken by China and Russia and others. And I would submit that our real chance to regain leadership is through the next generation of technology, because we can leapfrog with better technology and by having the best product. So, thanks.
I wanted to just say three things that we haven't paid a lot of attention to in this panel. Jay App showed you that electricity demand has been flat recently, but one of the principal vehicles for decarbonizing is electrification. And so if we get serious about decarbonization, electricity demand is likely to grow again. We've talked a lot about natural gas, and many people talk about gas as a bridge to the future, but you need an abutment on both ends of a bridge. And gas is 50% of the emissions of CO2 as coal, and so we got to figure out some strategy after we've decarbonized quite a lot with natural gas to keep going. And thirdly, we haven't talked very much, with the exception of some of the ARPA-E work, on the demand side. I mean, we've made enormous progress in this country in terms of more efficient appliances. For example, refrigerators today are cheaper, larger, and use less energy than they did 30 or 40 years ago. PJM, for example, has actually a market now for getting consumers to cut back. And so there's a whole lot of opportunity on the demand side that has not been explored in this session that's really important.
The transportation sector, I just want to add, given that many very serious pollution issues, namely particulate matter, NOx, are coming now from going to be dominated in the coming years by transportation, that is the driver for the electrification of vehicles. It's 1% of new car sales last year. China wants to be 11% of new car sales by 2020, 30 or 40% in the next decade after that. Why? Is it possible to control pollution of internal combustion engines, the NOx and the particulate matter? It's possible, but it's not enforceable. And because of that, India and China both realize the only solution is electrification. And that's, in the United States, personal vehicles is 60%. You probably go to 75% for short delivery vehicles. It's a big deal. That's going to be a game changer for both clean air, for health, but also for carbon. I think I'm very supportive of thermonuclear, but I have to say that as I'm a scientific advisor for one of these little startup companies, and I'm following all the others and the big ones like ITER and what's happening in inertial fusion, and I have to say it's really hard. And so you cannot hold your breath for fusion.
I think we have come to a stopping point exactly at 12 o'clock, so we've really met our timeline beautifully. Thanks to the audience for your wonderful questions, and again, thanks to the panel.